Hi once again, and thanks for inviting me. Today we're going to discuss about small language models in business, how they can be used, and about the current state of small language models. Well, first of all, we need to understand something about the LLMs. LLM is a very good response to majority of the use cases when we need to work with the text. And as we know, they have been trained on a very vast amount of information. It was trained on articles, on code snippets, on different texts, books, on voice recordings that were transcribed, on different type of images, and so on. And based on that, we increase the capabilities of large language models, giving them possibility to work not only with text, but further, even with images, even with voices, even with transforming some of the visual information. And actually, LLMs are pretty good. There's a problem. They are too big. This is just an example of how looks a very small example of the GPT. This is a nano GPT, which is based on GPT-2. And you can imagine how complex this system is. It's too complicated, it's too big. And we need to understand how we can make this smaller. And you may ask, why we may think of using the smaller models instead of the bigger ones? Well, there is a problem. Large language models are great, but they don't give you full control over the system. Imagine that you are dealing Imagine that you are dealing with a system that is always changing. For example, OpenAI introduces some new change to the policy of the GPT. And because of that, something changed internally in the system. And because of that, behavior has changed. That goes to different vendors, to different big models. While in case of launching the model locally, you're aware of full control over your model. Another point is that you are confidential because you are protecting your information. You are sure that you are not sharing this information with anyone else. And we understand that companies can train their models based on the information that we share with them. And it's not always good. You can think of different use cases in the business, even the pharmaceutical use cases, where the confidentiality is pretty important. So let's go a little bit back in the history. We can observe a very interesting change in the domain. Before release of GPT 3.5, there was a very small amount of small language models. And after the release of GPT 3.5 in 2022, people decided to try their best to make something very similar to GPT 3.5 and even GPT 4, but making it small, very small. And we can observe that different vendors try their best to make their versions of good small language models. It goes from Microsoft, it goes from Google, it goes from open source startups as Mistral and so on. And they try their best with optimizing those models and making them even more efficient. I think you've heard about the Mistral, which is using a very interesting concept of agents, where instead of just working with the entire model, it takes a very specific part of the model, which is very good at responding on this specific question. Like if you're asking about the code, it involves the code agent. If we are discussing about the literature, then it's literature part. And how we can construct a small language models. There are actually three approaches that we can try: distillation, pruning, and quantization. So what they are? Distillation is a very interesting process. Imagine that you have a very big, large language model. This model has been trained on vast amount of information. Companies spend a lot of money and effort just to filter this information, like removing any kind of noise, garbage that can have a bad influence on the LLM. And when we train the LLM, we can use its knowledge to train a smaller model called student one. So we give the knowledge from LLM, very curated, manually checked knowledge, transferring it to the student model. Imagine it like we have a professor and student, and professor shares its knowledge. Then we have another approach called pruning. Pruning is a little more interesting. Imagine that we have very, very big model that has a lot of neurons. You can even think of GPT, which has, by some suggestions, trillions of those parameters. And we just threw away those neurons that we consider that are not so important. For example, there are some hidden patterns that we are not interested in, some knowledge that we are not interested to share with this model. And because of that, we remove those neurons. So we exclude some knowledge just to make this model smaller. And there is another approach called quantization. It's a little more tag specific, but I'll try to be very simple about that. Imagine that every knowledge of the model is very precise. But what if we decrease this precision? Instead of having a very big size for each weight of the model, for each neuron, we try to decrease it and make it smaller. Yeah, we lose some accuracy of the model, and instead of giving a very good precise response, we're a little deviated into more improvisation approach, but it's still very efficient. And it is possible to launch this model on even smaller hardware, which is very good for us. And we can think of SLM as a dumber version of LLM on the surface, but actually they're not. We can observe that when GPT-4 has been released, a very big steps in advancement of those large language models almost has stopped, and everything that we see today is trying to experiment with different approaches of how we use the large language models. For example, did anyone use thinking models? Just raise your hand with thinking models. Did you observe how they work? They're trying their best with thinking about your response, and then based on this thinking that they generated, they try to give their response. This is an improvement of the large language model, but architecturally, they're not changed. They're the same. There is a difference only in the approach of how they respond to your question. And then we can observe that small models were improving a lot since the GPT-4, and that they were releasing more and more from different vendors. And each of those models had its own idea. For example, did you ever heard about the Phi model from Microsoft? A very good model. But there is a very interesting limit of this model. It's working mostly with English. And that's it. So with removal of most of the languages that can be used in the large language models, like, I don't know, French, German, Romanian, Russian, so on, we decreased a lot the necessity of the weights of the model. And then we need to think of SLMs as a much more efficient way to respond to questions because they're fast. Did you ever check or observe how much time it takes for some large language models to respond on your questions, especially when we are discussing about the thinking models? They're taking the time, and instead of giving an instant response, which is very useful in some use cases, they're taking their time. Imagine like you're constructing a very good, I don't know, electronic selling shop, and you want to set an electronic consultant based on LLM. It will take just tens of seconds just to process a response, while in case of SLM, it can be almost instant, which is very useful for the business. But we need to consider that SLM is not the perfect solution for every use case. It is good for very specific tasks. We need to understand that SLM is very good for being efficient, low cost, for being sure that you are confidential about your information, and you're using your own hardware and your own control over the system. Because of that, you can construct however system you want and whatever system you want. The only limit will be the amount of resources you have. Also, we need to consider that for some cases, LLMs can be better, like quick prototyping, like if we want a very good understanding of the broad series of knowledge, or if we have a very complex case, very complex logic that we need to handle. But we also need to consider that SLMs right now are approaching the performance of the big models. This is one of the tables that have been taken, if I'm not mistaken, in the spring of 2024, when there was a release of model from NVIDIA called Meditron 70B. And we can observe that its accuracy was even higher than the GPT-4. And once again, GPT-4 has around trillion parameters, while Meditron has only 70 billions of parameters. So by having the model almost 10, 12 times smaller, we achieve even the better accuracy. So SLMs are very interesting type of models. And once again, you need to consider some risks about using LLMs against SLMs. When you're using LLM, you're relying on the servers located at the company. Like if you're using Google AI solutions, then they're mostly hosted by the Google. The same goes for the Microsoft. And therefore you transfer your information, you're dependent from the third party, and they can, for example, shut down some of the models. I think all of you know about how GPT 3.5 Turbo was shut down, if I'm not mistaken, in the beginning of 2024. And therefore, a lot of companies had to switch their solutions to the new coming ones. And there may be some complexities about the changes of the models themselves. And for example, new filtering of requests, like you're asking something from the model, something changed in the policy of this company, and because of that, she can't respond right now on your questions. It was able to respond 1 week before, and now she can't. You can think of, for example, in the informational security. If you're a white hacker, any kind of question that you give to LLM will be met in most of the cases with, sorry, I can't respond on that. While in case of SLM, you can fine tune it to respond on those questions. And we need to understand that there are two types of SLMs and how we can use them. The first option is self-hosted LLM or SLM. It means that you're hosting your language model on the servers that are made by your own company. It means that you're in full control of the system, you're in full control of how they work, and because those are made for the companies, they can be even bigger than smaller language models. And they are very good and mostly similar by their performance with the LLMs. But there is also one more interesting case called Edge SLM. What if I'm shut out from the internet? I don't have the internet at all, completely. In this case, the only solution that I can have is called Edge SLM, because this model can be hosted entirely on your computer. And for example, I was mostly inspired by the Edge SLMs because they can be launched even on those phones. And we will review some of them today. So I'm not gonna yada yada about the theory. I'm gonna talk a little bit about the practical results. And because of that, we need to discuss a bit about the Edge SLMs and what they have been in the beginning of 2023. And it was a complete mess. Imagine that they were not able to respond even on some basic questions about some fact checks. They were taking a lot of time to respond. And because it was just a peering type of models, there were a lot of issues with compatibility, with making them work, with trying to make them be at least as efficient as some mediocre models. And because of that, many people thought in the beginning of 2023 that the idea of SLMs is dead at birth. But then, at the current state, a lot has changed. Right now, we have a lot of different architectures that we can use to be more efficient with our hardware. There are a lot of different techniques to make SLMs. They're a much better support of the libraries to launch them locally. And most of the solutions that you can use right now are just install and you're good to go. You're not required to set them up. You can just launch them right away. Just install the application. That's it. And today we're going to discuss a little bit about those applications. So we have two cases, Olama and LM Studio. They're very similar by their design and how they work, but there are some small differences. First, about Olama. Olama is considered to be like a golden standard of launching your SLMs locally because they have support of both NVIDIA and AMD GPUs, meaning that in case if you're aware of the prices for NVIDIA GPU, you can try AMD GPU, and it will even work with Olama. The second thing is that it works both as an application, which you just install and you're good to go, and also as a library for Python, meaning that you can develop your custom solutions, integrating them right into the Python, and they won't be complicated because this library is very easy to use. There is a very wide range of models available because Olama provides its own storage, or its own hub for the models. And it's a very good choice if you want to make your own self-hosted SLM or your own agentic system. But why you can think of using LM Studio? Well, that's a little interesting and tricky question. As we know, models need to be hosted on your hardware. And for example, some hardware can be very weak. But I'm interested in using a little bigger, a little better model. In this case, we can use a very interesting trick called partial offload. Partial offload gives you a possibility to use your entire device entirely with CPU, RAM, and GPU. And you can ask how it works actually, how it looks like. Well, I'm not going to dive too much into tech details, but imagine it like this. We have a possibility to launch the entire model in the GPU. But then we can make a very interesting trick. We give the model into the RAM, and then we just put in the GPU active part of the model, just the active section, and that's it. So we are using the most efficient part of our computer called GPU to launch the active part that is running right now, while inactive part stays in RAM where it is not occupying a lot of space and which is not used at the moment. And we also need to understand something about the LM Studio is that they are using a little different hub for their models called Hugging Face. I think some of you who is working with models knows about the Hugging Face, and there is a lot more models, even uncensored ones. And those who are not understanding the difference between uncensored and a simple model, imagine that uncensored model can write you a code to make white hacking, or even better understanding of the chemistry within even possibility how to make some forbidden questions and so on. And just for the sake of this presentation, we decided to perform some testing. As I mentioned, we have edge SLMs. Let's try them out. For that, I tried to use different models that are very popular at the moment. Those are Qwen, Gemma, DeepSeek, Phi, Llama, and Mistral. And they all have been launched in this case with Olama, purely on my RAM with CPU. And then for the sake of understanding, I was using it on the laptop with 8 gigabytes of RAM and 8 thread CPU. And the test was performed with 4 main topics: general knowledge, some coding with Python for anomaly detection, for basic use cases like sum of prime numbers, just basic algorithms, and for some context, like I'm giving to it a very big CSV and checking if it's capable to handle this CSV. And let's say that results were interesting. In case of general knowledge, most of the models handled okay. In case of code, they handled actually pretty good. Almost each model handled very good. just one model failed completely. It was called 5-4 menu reasoning. It was just a terrible experience. But all other models performed great. And there was only one use case in which they all failed. Only one. In the processing shop content. When I gave this CSV, they were not able to respond on those questions. So, as you can understand, Edge SLMs can be used mostly for generating some algorithms, for some general knowledge, but when you're trying to process some information like scientific paper, PDF, document, you name it, it will fail. But then I've decided to take a round two with LM Studio. Once again, I can use partial offload to my GPU, and it was launched on this laptop where I have just RTX 3050 with 4 gigabytes of video memory and 16 gigabytes of RAM. And I decided to try a little different set of models with better precision, but still which are very small. Tasks were almost the same, but I added a very interesting and more complicated use case with trying to find root of mathematical function based on bisection method. And once again, they handled, but in this case even better. In case of GMA3, 5.4, DeepSeek distilled with a Quen model, and Mistral, the performance was awesome. It was fast, it was very good with responses. The quality of the code that was generated was really good. The best code actually was generated by the Mistral, and it was just awesome, like the perfect even from algorithmical complexity, from all points of view. Gemma 3, which was quantized to even smaller weight, was okay. Quen 3 was mediocre. And then I decided to take a little more interesting case. We all heard about the agentic systems, like how you can make a very complex set of SLMs interacting with each other just to accomplish one task. And I decided to do exactly that, hosting it locally. I took one of my friends who has a little more powerful GPU called RTX 3060 with 12 gigabytes of RAM, of video memory. And we launched it on the Defy. Defy is a very popular automation tool which helps you to make everything in a visual format, like flowchart. And I've decided to perform some tests. For example, what if I want to learn something from scientific paper, but it's enormously huge? For example, this paper from Gemma 3 was 20 pages long. And what if I'm not aware of the AI overall? I don't understand it. I want to translate all of this paper in a more understandable and easy to learn language. In this case, I can use my phone. As we can see, we have several sections of our system. We have a decision SLM, which based on the request that was going from the user, tries to understand which scenario to activate. I have 4 scenarios in this flow, and here it understood exactly that I'm trying to extract the information from the document. And then I've passed this information to the model called OpenMistral Nemo. It's a very small model that can be launched locally. And as we can see, there is a very good response, divided by the phases, with a good coverage of the questions, with a very good translation of the topics into a more general knowledge language. Then I've decided to try once again my case with shop's inventory, with the laptops. And perfect response and perfect understanding from SLM, which intention I had, how to work with CSV, and it given me a very good result. And I've especially created those very specific names for the laptops to make sure that it won't hallucinate into existing ones, and that I will differentiate if it is basing on the CSV information. And as you understood, it handled the more complicated use cases. So in case when I, for example, just need to transform my email into corporative style, I can do so. I can translate even the information from one language to another. As for example, I've used translation from English to Russian just to see how it works. I've given a very strange written email to make sure that I will translate it into a corporative style, and it handled this use case. A much more professional style of response, which is more closer to corporative style. And as you can see, with SLMs, we're capable not only to construct the solutions that can be launched on our laptops, but the solutions that can be hosted by ourselves, even very complex systems, as in this case, because it was overall running just on my friend's PC, completely, locally, and that's it. So we're going back to a little bit of theory, just a little bit. You need to understand that almost in all cases, when you prototype your solution and just checking the capabilities, you're good to go with LLMs, because once again, LLMs are great for everything. But then you can try SLMs just to make something specific, some specific response when SLM is being good at something precise, like on a very narrow task. Just divide a very general task into a series of narrow tasks and it will perform much better. Because SLMs are not about being the best models. They're not about being the most speed, the most fast models. They're about being efficient. They're about being very cost efficient. And that was, as was mentioned at the beginning of the session, LLMs are too costly right now. So we need to reduce the costs because business is always about being efficient with a very low cost. SLMs are exactly about that. Thanks. Yep.
Are there any projects in Grid which are using SLM?
Sorry?
Are there any projects in Grid Dynamics that are using SLMs?
Just to repeat for the presentation, there was a question about usage of grid of SLMs by Grid Dynamics. The problem is that I'm from a different company called BackstageIT, but I can tell, for example, my case because I'm working for one pharmaceutical company, and we, for example, use SLMs. We have a very good case of using LLM for general knowledge, like based on the documentation system that we are using in the company. And SLMs are more about the local use. For example, you are a worker of this company and you don't need to share your information. And we decided to use a model called Phi4 from Microsoft because it was very good with keeping a little bigger context and it was capable to give very good and fast responses because the requirement for this model with Q4 quantization, 3 gigabytes of RAM. That's it. It was very fast with responses. Just imagine like 7 words per second, something like that. It's a very good response. And it is a very good thing just for general use cases, especially when you don't have a very big context to share. It's perfect. So yeah. Thank
you for the presentation. I have a question. SML, is this less than 10 billions, right?
Once again?
Small model should be less than 10 billions parameters, right? Just for the reference.
Actually, it depends because each developer gives its own definition of small language models. Some give that it should be less than 10 billion. Some say that it should be less than 15, something like that. Yeah. Yeah. Completely locally. In case of Llama and LM Studio, they were hosted exactly on this laptop and even weaker one. While in case of DeFi, I used the PC of my friend, which had a GPU with, once again, 12 gigabytes of video memory, which is also not so much. And
Regarding Llama, is this alternative to Hugging Face? Because I'm not familiar with this one, or they're complementary to each other. Because it looks like you can upload the model from Llama and then use it locally, but you can do the same for Hugging Face. So is this like alternative things?
Just once again to repeat, there was a question about if models from Hugging Face and Llama are like concurrence or like yeah, like different stages, and yeah, those are different stages. For example, Olama is a very good hub for official models, for example, ones from Google, Microsoft, Alibaba Group, from big companies, and mostly it's used by them. In case of Hugging Face, it is a community hub where you can upload your own model. The difference is that, for example, Hugging Face is a very good storage even for uncensored models, while Olama gives possibility to host uncensored model, but they're not available for internal search. The only way to find uncensored model in Olama is to go with Google search. And that's it. Yeah. Yep.
Is this about assigning different device maps for different layers? For example, layer 1 to 10 will go to CPU, 10 to 20 to CPU. Is this such kind of practice, or is it different?
It's like the thing about partial offload is that it tries to load only the active layers of the model. In case if we use the classic SLM like Llama or Llama based solution, it tries to load active layer. When it's done, it deloads it and goes with active layer, deloads, goes with active, and so on. And for example, in case if we're interacting with agentic models like Mistral, there are like several experts, like 7 experts in the model, and it loads just the active one instead of loading the entire model into the GPU. And because of that, it is much faster than running entirely on just RAM and CPU. And because of that, it is like almost instant response. And because of this partial offload, you can take even bigger models. Like on Olama, you can take models with 8 billion parameters, while in case of LM Studio, you can take 12, even 14 billion. On this machine, I had the possibility to take on Olama just 8 billion models, while with LM Studio, I could take even 12 billion, even 14.
Model smaller via quantization, like for example, 4-bit.
Actually, the question was about shrinking the model size by different tools. Well, Olama tries to quantize the models mostly. It's like about taking the model itself and then trying to make a quantization where you're just reducing the weights by their size. So model right now becomes not so accurate. But in case of LM Studio and Hugging Face, it's about more different approaches. If we go a little back in my presentation, you can even see name for one of the models called as DeepSeek R1 Distill Quen. So the idea was that they took a very small Quen model, which was trained by DeepSeek R1 to be as efficient as DeepSeek. And Hugging Face gives opportunity to upload almost any type of model, which is distilled, quantized, and so on. And yeah, they share some tools which you can use, but mostly you're interested to trying different specialized libraries, like the ones that are designed exactly to work with decreasing those models. And also, there is a big difference between the LAM Studio and the Llama. Olama gives you an option to integrate solution in the code, while LM Studio is more like a standalone application. This is a very big difference between them. So,
and if possible, one more question. Let's say I'm using one of the small models,
yep,
and it works.
Yeah.
What kind of tools I can use to monitor hardware requirements to make an inference? For example, if I use model which is twice as large, how much resources I would require to make it work? Can you recommend some observation tools how to understand why, for example, my question took 1 minute to answer?
Yeah. If I understood correctly, you're speaking about using some cloud hardware, or
how I can improve my model, or what kind of resources I need to buy or upgrade my laptop in order to use a large model.
For this, mostly you're speaking about the just to use better models, you mostly need to buy a better GPU. In most of the cases, you're speaking about the NVIDIA GPUs, and some models have compatibility with AMD. And as I said, Llama gives a layer of compatibility with AMD models, which are cheaper. And mostly, you're about buying a better GPU. In some cases, you need to think about trying different model. For example, I had a very good thought about the Quen models, and when I performed my tests, I suppose that the best response will be from the Gemma and from Quen models, while actually the best responses were from Gemma and from Mistral models, which was a little out of expected result to me. And Phi, for example. Phi is almost, by my opinion, the best local model that you control. Yeah, yeah. I've especially designed them in English, and in case if you need a multi-language support, for example, you should target Gemma, because Gemma has one of the best multi-language supports. Quen also has, but it's more narrow, and in case of Phi, it's mostly about English. So try it out, and I think you will have results. So either you need to find some better hardware, or you need to try a different model, and that's it. And in case if you're very limited, but you need a very good response, try to find uncensored. In most of the cases, they respond better. Yep.
Just want to ask you one interesting question.
Yep.
You mentioned at the beginning that GPUs are very expensive.
Yeah.
So basically, there is a flow, at least right now, that is getting a lot of traction.
Okay.
A lot of starting to migrate to ARM architecture.
Yeah. Yeah.
And they're basically buying Mac Studios, and
Yeah.
they're running SLMs there.
Yeah.
That maybe even LLMs if they're paying for the biggest.
Yeah.
Like let's say for 94.
Yeah.
So what do you think about it? Have you had any experience of running that? Is that interesting for you?
Actually, that's a good that's a good continuation of your question. Even so, the question was about using the current ARM-based laptops, mostly about the Mac for running local SLMs. Yeah, once again about that friend. He tried once again to make his self-hosted SLM, and because of that, he decided to try on the MacBook because it was very popular, and he thought, well, okay, I need to try it. We had a MacBook M1 with 32 gigabytes of RAM. And I can say for sure that, yeah, it was very fast. It was very good with running models locally. The only thing that I'm not a fan of macOS system, but that's my problem. But actually, Mac laptops are very good for hosting those SLMs, and they're behaving very good. And the main fact that I liked that they're very easy to set up, very easy. Yeah. And yeah, actually comparing their prices to the GPUs, like this laptop my friend he bought for $1,000, while this PC with 3060 he bought for $800. And in case of his PC, we could run only the 12B models like that, while in case of MacBook, we could launch even 20, even 24B solutions, even better ones, and even ones that are not with quantization. So even the full models. And yeah, it's a very good experience actually. So if you have the money, you're not against the macOS system. And if you want to switch easily between the models, yeah, you could try.
Unified memory as
Yeah, yeah.
because you basically don't have the restriction of using only your RAM or using
Yeah,
only your
yeah.
DRAM or making it hybrid, you just use it as it is, which is
Yeah,
really
exactly.
nice, especially when you want to deploy bigger functions.
Yeah, it's better from terms of also energy consumption, as I understand. The only problem is overheating. Just imagine 100-degree laptop. Well, it was a very interesting experience. I was even smelling that something is like like close to fire or something. Yeah. Yeah.
When you are picking those up and you're comparing with the new ones, you just remember how bad things were previously
Yeah.
when they were running on it.
Yeah. Well, this thing is running on AMD processor, and the performance was actually okay. But yeah, the M1 based solutions, M based solutions are better for this case. Any more questions? Yeah. Yeah. Yeah.
Which criteria is based to the selection and how is it made this decrease?
That's a very good question, actually. There is an investigation performed by Anthropic. If I'm not remember, I don't remember the exact name of this science paper, but they made a solution for tracking the neurons that are activated based on response. So the first stage can be tracking the neurons that you don't need. For example, imagine that I want to use SLM designed for coding. Why do I need knowledge about the Kishinev inside of this model? I need to be purely about the code. In this case, those neurons are tracked and removed. Another section is with trying to experiment, like you remove one section of neurons, check how bad is the response. If it is too worse than expected, then you removed something crucial. It's more about the experimenting with removing different types of neurons and where you remove them and trying to not to break the model itself. So it's either tracking by advanced tools, like in case of Anthropic, or it's about experimenting, where you just try not to break everything. Because the biggest problem right now about the SLMs and LLMs is that they're so huge that it's very hard to understand. I don't want to say how they work, but how to trace where exactly the photo is going, like how it passes this information through the layers. While we understand how they work in general, in the precise information like how it passes, it's more complicated right now. So yeah, it's either experimentation or tracking. Yeah.
Did you try integrating SLMs with RAG?
Actually, yeah. Like as I've mentioned, this model, which one? Yeah, 514B, and which one? And this one, 54 Mini. Once again, as I mentioned, in pharmaceutical company, but which I'm working. The idea was that, as I've mentioned, we are passing the documents that were used within the company, but we're not passing them directly, but we're using them as a reg. So there is a very good embedding system that is running locally, and she gives back a response, like, for example, from which documents most likely we need to take information. Then 5.4 takes like a summary of this information, and based on that, it gives a response. There is a very good advantage in the recent SLMs. When it was back in the beginning of 2023, they had a very small context window, like 8K tokens, something like that. Like imagine like 5 A4 pages. But right now we're speaking about giving entire books into the small language models, and they can handle that. Especially if we speak about Gemma case. Gemma case is good not only for multi-language support, but also with a context window. Mostly we're speaking about 60K, 16K, 32K. But in case of Gemma, I'm sure that it's 128K of tokens. So that's close to GPT-like models. And that's a very good result.